Alright, so in this video I'm going to very quickly go over why we want to window when we design FIR filters. Alright, so by the way, these figures come from an introduction to digital signal processing by Blanford and Parr, written in 2013. It's the first edition, and the figures in particular come from pages 222 and 225. I just want to give credit for these figures. Alright, so first thing I want to point out is that typically when we are in the time domain, we have an ideal filter, and that ideal filter has an infinite number of taps because in the frequency domain we want a perfectly rectangular looking filter. So an ideal filter, if I really start from here, it should look so let's say this is step one. I want an ideal filter, and in the time domain it looks like an infinite number of taps, and unfortunately that's not exactly what we want. We really want a finite number of taps. We want it to be really limited because we have a computer. It needs to be able to do something with it. And so what we do is we apply a window, which is typically rectangular to this, and this is actually going to cut off the weights of our taps. And so this is a really crudely drawn rectangle, but it's going to look something like this. And then the problem, though, is that if I have a rectangular window function, that looks like a sinc squared in the frequency domain, or a sinc in the frequency domain. And so if I convolve those two together in the frequency domain or multiply them together in the time domain, the good news is that I have a finite number of taps, which is great for implementing a computer, but unfortunately I get crazy ripples in the frequency domain. And so the idea is that we want to use an alternative window function that's not a rectangle to replace the sharp edges to limit our coefficients. And different forms of windows can reduce the crazy ripples in the F domain. So to see the table from Blanford and Parr from page 225 in that textbook, here's a set of possible windows with their MATLAB representations. Now, you'll see that this notation is a little different than what I'll carry on going forward, and so you can read this, you can see what are the MATLAB commands associated with it, but then in the next video what I'll do is I'll go with my own notations.